episode 18 of the World of FPGA podcast. In addition to the last episode, we will now have a look into the process of debugging an ARM core software. Welcome to the World of FPGA podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. As mentioned in the last episodes, we will go a little bit deeper into the debugging stuff. And after we have the last episode with debugging an FPGA, we will now switch to the ARM core. And again, it is more or less Xilinx or better AMD based, but you can transfer this knowledge also to other manufacturers. We will talk about ARM cores inside an SoC, for example, like it is in a Zynq. And there are different ways to debug your ARM software, your ARM core, and I will go again through three steps or three different variations of debugging this kind of ARM cores. The first one is we are using our UART and we are using printf in our C code. This is a very classic way in software development, and this is used all over the world and in every source, on every software I know. You have printf and you are printing out debugging information while the code is running. It will just follow your program, and at the end you will look into the results. Maybe you found more or less easy than the different bugs in your software, and then you will create the next version of your software and also run all with the debugging printout. And after you are done with all this stuff, you will smash away all the debugging printout or printf in your code, and then you have your ready software. This is one of the easiest way to debug software, but it is not in the original way how to debugging something. You cannot go into the code directly. You can only see what the code is done while it is running. This brings me to the second variant here. We are debugging our bare metal application in Vitis. A bare metal application runs without any operating system. Well, this is possible also on a Zynq. We're not always using an embedded system. We're just developing a bare metal application which doing for example, some communication stuff or some real-time stuff or something like that. And it just runs without any operating systems, just runs directly on one of the two ARM cores. And if your SoC has two ARM cores, you can also run two different softwares on the two ARM cores. Yeah, and here also UART and printf will work fine because we have two UARTs on our processing system on the PS in a Zynq, and we can just configure one of the UART to be our standard in and standard out, and printf will use this UART just to bring out all the information you need. But there's a more efficient way in just using a real debugger, and the Xilinx, or better AMD Vitis development platform has an integrated debugging feature, not only creating firmware. We can just directly debugging inside of this development platform. And the Vitis using the exported hardware file from the Vivado. So inside of this, in Vivado, we are creating our FPGA logic. We are configuring the processing system, for example, which frequency we have, the UART, which baud rate we have, and all the other interfaces are configured inside Vivado, and we are also doing our FPGA logic stuff there. And after that, we are exporting the hardware from Vivado and importing them into Vitis. We are creating a platform project because the hardware is our platform on which is our bare metal application, which is running the bare metal application. And we're also creating here our first stage bootloader, that's for sure. And then we can create our application project. We are writing our application project with our signals and our control mechanisms and some UART stuff, for example, and some state machines in software and so on. And if you are done, we are compiling it, and then we are using JTAG to program and debug all the whole application. And the interesting thing is, in the exported hardware, we can integrate our bit file for the FPGA and the Vitis platform, configure the FPGA, and then start the bare metal application on one of the two ARM cores. And then we can debug and going through the code, stepping through the code, find our bugs and reading the memory, reading variables and so on, doing all the stuff we can do with a standard debugger. Well, and at the end you can finalize your bare metal application and just bring this out into the world. This is the one version how you can debug your application. That's a bare metal application, but it could also be you want to program an Linux application. And this is also possible in Vitis. You can use Vitis to debug your Linux application. So you have to, so a Linux application is running under the embedded Linux operating system as an application. And you are in an operating system, you can just use all the routines and drivers from Linux, and also UART and printf will work fine, but it is again more efficient to use than debugger. And the Xilinx Vitis has, as development platform, the capability also to debug an Linux application. But first, you need an embedded Linux, for example, PetaLinux. You can just create it, your operating system, your embedded Linux. Then you have to export the kernel sources and libraries into Vitis. That's quite easy and quite easy to configure this. And one important hint from my side here, the version of the compilers and the version of the libraries must match. So Vitis 2022.2 and PetaLinux 2022.2 will work very well together, but Vitis 2020.2 and PetaLinux 2022.2 will not work together because the newer PetaLinux version will have a newer compiler and newer libraries. So when you're just writing your software in Vitis on your host PC, doesn't regard if you have Windows or your Linux or something like that on your host PC, and on the target, which is running under PetaLinux, there is a debug server application. This is standard in the PetaLinux project and it's always included. You can throw it away if you have a system ready to ship, but as long as you're debugging your software or creating software, you should have this debugging server application running. The connection between the debugging server and the Vitis debugger is via Ethernet. So your device should have an Ethernet port. Maybe you can add it via USB or something like that. But you will need an Ethernet port. This is quite easier to communicate between the debugging server and the Vitis debugger. And this is very high performance. And if you start debugging, the Vitis and the debugging server will communicate, and copying your compiled ELF file to the remote system to a defined folder, for example, on an SD card or on the temp folder or something like that. And the debugging is started on the target, and you will go through the code on your host PC, and the communication between the host and the target is via Ethernet. And this is quite awesome in developing embedded software. It makes it so much easier. You can also use some emulation and something like that, but it is the easiest way, in my opinion, to have the target and to debug the software on the target, but from your development system on your host PC. Yeah, and now I think you have many ideas how you can create and debug your own application. If it is bare metal or if it is a Linux application, both is possible, quite easy. For example, in the sightings world. Yeah, and some further information can be found at world-of-fpga.com/WFP018. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye, here next time, your David Kirchner.